Cutting parameters decide the part quality, proper chip breaking, tool life and tool cost. It is therefore very important that you select the correct cutting parameters that suit the operation, the tool material and workpiece material. Here are a couple of examples of improper cutting parameters. This video shows chips not being broken properly because the feed rate is too low for the insert being used. This video shows chips being broken properly, which means the correct feed rate is being used. Every cutting tool manufacturer has cutting parameters tables in tool catalogs. To decide cutting parameters for an insert, we just refer to the catalog of the manufacturer of the insert. This chart, for example, is for Tegutex catalog for turning inserts. To understand this explanation, you will need to remember some concepts that were covered in the earlier lecture on cutting tools, like negative and positive inserts and insert grade. First, decide on the insert style, whether you want to use a negative or positive insert. A negative insert is stronger but also results in higher cutting forces. So you would use it when taking heavy cuts or interrupted cuts on a part that is held firmly and can withstand high cutting forces. A positive insert is weaker, sharper and results in lower cutting forces. So you would use it on a part that is not held firmly, is likely to bend or has thin walls. Based on negative or positive, look at the N or P rows in the first column. Now decide on the application, roughing, medium machining or finishing. Medium machining is merely roughing with a smaller depth of cut. Based on this, look at the F, M or R row in the second column. Now decide the depth of cut that you want to use and look at the corresponding row. If you want to use a depth of cut of 3 mm, for example, you would look at the row 2.5 to 4. Now decide in which category your workpiece stability and machine condition falls: best, normal or poor. Best would be if the machine is in good condition and the workpiece is held rigidly, is not likely to bend, has no scales, sand inclusions or blowholes. Poor would be if the machine is in bad shape, vibrates a lot, and the workpiece is not held rigidly, is very long or has thin walls, or is a casting or forging with scales and sand inclusions, or has a non-circular cross section, which involves a lot of interrupted cutting. Normal would be between best and poor. You finally now get the grade and chip breaker geometry that you must use for the operation and the corresponding cutting speed and feed rate. In the fifth column, row number 1 is the first choice and row number 2 is the second choice. Ideally use the first choice, or if you do not have it on your shop floor, use the second choice. The highlighted rectangle on the chart shows an example for cutting 0.45% plain carbon steel. We want to use a negative insert, do medium machining with a depth of cut of 3 mm, and the machine and workpiece stability are normal. We therefore use an insert of TT8125 grade with a PC chip breaker, a cutting speed of 280 meters per minute and a feed rate of 0.35 millimeters per revolution.